Hello, everyone. So, okay, I'm seeing everything here. Okay, so hello, everyone. It's a pleasure to be here once again. So I was here last year talking about the vision of Bentley Systems regarding digital cities and flood resilience in cities, in urban environment. So this year I will talk a bit about that, but I will go with some use cases and some examples of implementation of this vision that we have. So I'm not going to lose too much time on these slides because the context is already there. So it's just some data about the increase of precipitation in the last 50 years on the left. In USA, in the right, what you can see is what is expected during this century if we keep the same emissions that we expect that will happen if we don't do nothing. So this is Europe, and also the same increase in extreme precipitation. You see some specific areas here where the rainfall, extreme precipitation is increasing in intensity and also in frequency. What we expect for the future is that the number of days of extreme precipitation will continue increasing every year. So, in fact, we expect that urban flooding and climate changing will have not only environmental consequences, but also economic consequences. So this is just a map with a different projection for the future in distribution around the world. This was usually discussed in the last presentations. So the main points that I want to highlight here before going to the examples that I will show is to talk about the holistic view, that the holistic approach and the integration of processes and scales that we need when we talk about floods. So usually, if you go, for instance, if you go to a city or an urban environment, you have several different variables and processes and scales. You have the watershed scale, you have then the river scale, you go to urban, then you have all the urban drainage systems that are in interaction also with the surface, eventually with the coastal areas and the rivers. So you must take all that information in account in order to try to study and to represent the urban the integrated water cycle in an urban area. So this needs a holistic model approach to try to study this. So that's why in Bentley we have implemented this dynamic modeling approach, integrating the rivers and channels with the surface runoff and the subsurface collection systems as well. So this was something new last year that we have now available in our software. This is just to show, well, probably you can see very well, but it's just a comparison between studying a 1D and plus 2D simulation, so having the flood on the surface runoff, and comparing results with only a 1D simulation. So if you're just doing the 1D simulation, you're just simulating the water that overflows, and once it's in the surface, you remove it from the system. So there's no interactivity between the surface and the drainage network. And the fact is that when you have a conduit surcharge, the water overflows, but it can again goes to the surface. And that's, let me just move to the next slide. That's when we compare the flow on the nodes of your pipes. You compare the 1D only with the 2D plus 1D, you find out that the results can be quite different, and you might be underestimating if you're not integrating the surface with the subsurface. So just to give you an example of how important to have this holistic and integrated approach. Okay, so going to the vision that Bentley has. So the idea that we have in terms of digital transformation and digital cities is to implement a digital twin. So the whole philosophy is to have a connection, a bridge between the physical and the digital and the virtual world, somehow with dynamic exchange in information. When you change something in reality, you should have the reflection on your screens and on your maps and your GIS. So use that in real time and have that information as reliable as possible will bring productivity and efficiency to the decision making. It will be better for the people that are behind this system. So, and when we talk about digital city and digital twin workflows, my focus here is mostly on flood resilience. So what we have is that flood modeling software is able to connect not only for making optioneering, to studies, to make scenarios, to designing, to master planning, but can also be used in operations. And when you have a problem, for instance, a pipe burst, you should be able to see the impact of a pipe burst in your network. If you have a rainfall, a storm event, you should be able to understand if you will have the water quality affected by a discharge, emergency discharge in a coastal area as a result of the problems of the rainfall. And you should do this as fast and as easy as possible. So that's our philosophy. So the software is not only for planning, but also for operations and response, emergency response. And so, just to show some workflow that we have that we have shown before. So you can start by collecting your information from the surface with drones. Then you can build 3D reality mesh models. But then that information can also be used in the surface flood model because you will have the topography and the topology. The subsurface information can come from sewer jams, a model that is able to represent the stormwater drainage network. And so after this, you run the model, you can run it in an operational way, and then you can also connect to flood early warning systems using the data you collected and have powerful visualization platforms in 3D and 4D with variation in time and in the 3 different spatial scales. So this is the kind of workflows that we have. So the main idea is to connect all the data that you have from several different departments in a company and use all this GIS, meteorological data, sensors, everything working together to work for the flood resilience and flood mitigation and flood analysis. So going straight to the examples, it's easier to understand when we show the examples. So in Helsinki, for instance, this is just a video with LumenRT, a visualization tool. So we are seeing a 3D reality mesh model. At the same time, what we see is the network, the stormwater network that we have here, and we are visualizing the profiles and the streets. So they have, for instance, a conduit surcharge with water coming from the subsurface to the surface, and we can see the flood result here in a mixed reality where we see the reality mesh model with the open flows flood results layer here in the same map. So at the same time, Helsinki, we have also developed some storm surge modeling scenarios for the city of Helsinki. And at the same time, we can use this kind of immersive visualization technology to engage with the users and to decision makers, because they can navigate through the city and to visualize how a flood would spread or how it would propagate. So it works in both ways. So we collect information from drones, we build a 3D model, and then we use it for the flood simulation, and we mix them together and we visualize the results as we are visualizing it here. So we see the variation in time, and we can navigate over the city. Now, once again in Helsinki, there's a different platform for visualization. So this is Open Cities Planner. The idea here is to have different layers, and this is to be shared with the community and with the city. So we are visualizing flood scenarios on the same platform where we can visualize several other data. So this case, this is web-based. The other one was on a desktop. This one is a web-based tool where you can visualize these different flood risk maps or other layers that we have. So just another example, this is São Paulo. So they just had some problems with floods in the last month, I think, with some casualties there and some damages. So once again, what we have implemented here for São Paulo is the 1D to D flood model integration. So we are able to visualize the results. So the water here, my colleagues just build the model with a different color for water, more close to reality, because in fact, what they have there is sewage, and the water that they have there is from this color. So they have several problems here. Whenever they have a storm or a rainfall event, they will have this area flooded. And so we can visualize the same way and integrating the information for São Paulo, which can be useful for some specific analysis. Well, pretty much the same as Helsinki. Now we have this case. This case is a bit different from the others, because in this case the focus is not on the reality, on the 3D mesh model. They are more focused on different types of data. The main idea in Porto municipality was to reduce the number of data silos, several different information coming from several different places. They wanted to bring everything together, data from sensors, SCADA data, models, GIS, topology, everywhere. So they wanted to put everything together. So this is just an example of modeling work that we have there, and to show the integration that they have done. So if they have a rainfall event, is what we see here. So Porto is here. So the rainfall generates a pressure over the drainage network, over the urban drainage network, that has some emergency discharges here in the Douro River, and also here, the outfalls. So they generate water quality problems in the bathing water place. So this is the closed loop in terms of integrated urban water management. So from rainfall droplets till the fecal coliforms that reach to the bathing waters. So this is the web platform that we have generated in this project, this awarded project with Porto City. So they are able to visualize all the SCADA data, pumping stations, reservoirs, all this information in a unified platform on the web. They have all these alarms. They have meteorological information in several different places. The water supply network, dynamic water balance, computed every month for their cases. So they have the modeling simulations. They say they can visualize the wastewater treatment modeling, coastal currents, and also some dashboards with the fecal coliforms for the next hours. So that's the information that we are providing for them. And they can also make simulations on demand. So if they have a pipe burst, they click on a point, they put the information, and they can visualize the results immediately. So that's the idea in Porto project. So that project connects water quantity with water quality, and it's the same here on this project. This house runoff project, this is a European scale project in several different places. This is for civil protection, and the main idea is to have a flood early warning system that is able not only to handle the flood events, but also water pollution that can result in the same areas. So the main objective of this project is exactly going digital, is to avoid this, well, not to avoid, but to complement this paper of flood risk maps with dynamic risk maps, because the information, the flood risk maps, the static information, due to climate change, it's becoming outdated, and it must be continuously updated. So this is the web platform that we have generated for the flood early warning system. In this case, we are seeing France. It's the Loire estuary, so we connect the whole watershed to the river and to the estuary. So we are able to select the region. Then we see meteorological data. There we see the whole watershed with river flows and whatever. We also integrate remote sensing from a company which is EOMAP, which is a partner, so we can visualize in near real time all the information. In this case, we are visualizing turbidity in the estuary. And we also have the ability to upload images, GIS images that can be collected from a drone or whatever, and you can upload it to FTP, and immediately you visualize it mixed with your model data as well. Dashboards where you can cross all the information, compare models with data that is measured across the rivers. And yes, and so I think my time is finalizing, so I'm just going to spend 2 minutes here showing these examples. So this is not a city. This, in this case, is a micro city, as we call. This is an oil and gas. It's a chemical plant in USA. So this is also an interesting point, because they collect every 2 weeks or every week. I think right now it's every 2 weeks. They are collecting information with drones from the surface. So they update the information from the surface because it's under construction. It's a construction phase. So what they want to do and to know is what is going to be the flood over the surface due to rainfall, having in mind that the surface is always changing. So they want to optimize their operations and to protect their assets. So in this case, we have an operational flood simulation system that is continuously updated whenever they have different information from the digital surface. So this is the website where they visualize results. They can also visualize the latest and the most, well, the estimated rainfall conditions for their location. Finally, ongoing study with an oil refinery. So these areas, for instance, during Hurricane Harvey, they were affected. So in Texas and other places, they were several affected by the storm. So a lot of pollution was caused by the floating of these oil tanks. So they need to put more oil to avoid that the oil tanks will float whenever they get flooded. So what they are now trying to analyze is how to optimize these levels in the reservoirs in order to avoid the problems. So they are making studies with this, try different design flood models, study different conditions. Well, here what they have is trying to put a culvert in different places and try to see if it will change the impact over the flood. So they are trying to remove water from the site with just doing up some optioneering, some scenarios in order how to make the decision to reduce the problems that they have. So in fact, in the beginning, the culvert seems to change a bit the water column here in this point, but the fact is that after some years, some hours, the situation is the same, even if they have a culvert. There is no capacity to remove all the water from one side to the other. So this is just an example of the studies and the use cases that we are doing using digital twin approach. So take-home messages. The main idea is an holistic perspective. Try to integrate all the processes and scales that are involved. You should have software that is able to integrate all this information, otherwise the results will be biased. from what you expect. And this sentence, everything is connected, it's because you have data from several different data sources, but you should be able to put them together and to take the benefit from there and to build these digital twins where you can exchange information from different departments, different disciplines, and take better decisions based on the data and the knowledge that you collect from all this data. So that's the message that I have. Thank you very much. Just to say that we have a booth outside, so my colleague will be there. We will have a lottery tomorrow, I think, in the coffee break. So just go there and ask my colleague, how can you go to the lottery? It's not money lottery, but it's books that we will provide about water and wastewater information. So thank you very much.
Dziękujemy bardzo. Również zapraszamy do pozostania z nami.